right, hello out there in TV land. It's time for another coding challenge. And man, I tell you, I got really scared a minute ago because I went to leetcode.com and I went to go, what? I went to go click the Leet Coding Challenge and I noticed it said June. Day 29 of June. I click it. Oh, and it takes me to a new month with no problems completed. Click here, no problems. Luckily, if you click that link, it takes you to a place where you can click on the May challenge. We've got 2 days left, is that right? 3 problems left before the end of the month, so I was going to be very upset if somehow I missed out on finishing the contest. Not that I expect to win the backpack or whatever, but you know, I'm 29 days into this thing. So anyway, here is today's problem. And I already know what to do about it. And so it's just a matter of bungling through it, I hope. This problem is course schedule. So there are a number of courses that you have to take from 0 to something. Some courses have prerequisites. For example, if you take course 0, you have to first take course 1, which is expressed as a pair. So course 0 depends on course 1. And given the total number of courses and a list of prerequisites, is it possible to finish all courses? So this is basically like the definition of a top sort problem, a topological sort. And that's where you basically take a graph, and there's a couple reasons why you would use this algorithm, but like the textbook example is basically scheduling, trying to figure out if something is possible. Hey, what's up? DP problem, except I know the solution already. I don't know that DP is necessary. I'm pretty sure that just topological sort. I don't know that I remember how to do a topological sort, but the other way I've heard it expressed before is like if you create a tree, then you can pluck off a leaf node and then pluck off another leaf node. And if you're ever at a point where there are no leaf nodes, then it's not. So I think that there might be some way to do it dynamically, but the way I've always heard of problems like this or seen them or done them is basically either doing a topological sort, which is basically just DFS with a twist. And I don't know if I remember what the twist is. Or you do the trick where you create like a tree and then you remove the ones that have no dependencies. I'm hearing strange sounds. I don't know what that sound means. There's always something funky going on. I always got some new drama-rama. Let me fix chat real quick. Whoa. So, by the way, the only reason I know that this is top sort is because at one point I did a bunch of top sort problems because I ran into a problem like this that I didn't know what to do about it. We got hints. The problem is equivalent to finding if a cycle exists. Okay. It doesn't have to be all nodes reachable, because you can have islands. You can have ones that are have no dependencies, and you can finish those. Yeah. So top sort via DFS is the hint. There's a tutorial. Top sort can also be done via BFS. I believe them. I'm tempted to Google it to see if I can remember the twist, but I think basically the deal is you need some sort of like a mutable list that's going to be like your result. We don't care about the result here. Mutable list of, and we need kind of a special, the twist I mentioned was reversed. I don't remember the twist. Oh no, did I have it and reverse it? Just need to reverse it. So I think you need to have like a list that's basically like one possible answer, because you can have multiple potential solutions. You just need to know if you can have at least one. So in order to do this, basically you want to loop over the number of courses. So something like for C in numCourses, I don't know, something like that. And then this makes sure, and this is like similar to the problem yesterday where I got stuck with islands, and then remember this little trick. Basically, I don't really remember yesterday's problem other than doing this in order to sort out the ones that have no other relations. And in here, we're going to do a standard DFS, but inside the DFS, we need to track oh geez, okay. I remember something about colors. It was something like there's like three states. One is like never seen it before. One is seen it but haven't processed it, and another is like done. And once an item's done, it means it's basically we've reverse post order DFS. What? Reverse post order DFS? I don't know what that means, so I might be in trouble. Basically, when something is done, like totally done, we can add it to the list because its dependencies have been resolved. And at the end of this thing, we'll know if we've got a cycle in our graph, basically meaning there's some sort of cyclic dependency. Adjacency list. Will that help us here? My default is adjacency lists. I hardly ever do the matrix. Yeah, we can't do a matrix here because we could have... Oh, that's an interesting way of thinking about it. If you're just... Oh, no, okay. I was going to say if you're just looking for cycles, you could just do a matrix. And then if you ever try to put in numbers, but then that doesn't take care of the problem where you have like a tertiary cycle or some sort of like, you know, bigger cycle. So yeah, I think adjacency list is the way to go. You don't need reverse here. Okay. Oh, yeah, okay, Adjacency, I gotcha. Yeah, for doing a true topological sort where you need to actually come up with the list that is things in the right order, then there's like this weird trick where you like reverse the dependencies. Oh man, I don't want to Google it. It's on the tip of my tongue. It's like you reverse it and then do the DFS. And if you're able to put all nodes in the done list, okay, I'm getting lost. I think this is going to work though. Basically, we start at, we'll call this list the done list. We loop through the number of courses. And we'll have a data, I guess it doesn't really need to be a data class, but we'll have a class that has a node, that represents a node. And in it, it will have the value, which is integer, it's immutable, and we'll have a mutable variable that represents the status. We'll call it status. And I think it's okay to have it be Boolean because if it's never been seen before, it won't even be in our list. So our mutable list of items can be integers because this is I don't know, I'm still thinking about that. And what I want is basically something for quicker lookup. So I want like a map, mutable map of, and in here, what do I want? What do I want to look up by? I want to look up the key, and I want to get the status. So I don't really need a data class here, do I? I can just have a Boolean for whether it's like done. And then that way I don't have to search the list. Getting attacked by wild dogs. A mutable set. Yeah, why not? Why do I need a list? I don't care about the order. So mutable set of integers sounds good. Yep. All right, so we're gonna loop through all the items. And then in here, we need to do a standard DFS. So basically, if, well, maybe I'll call map status. If the status, or if status contains C, if it contains my course, then what does that mean? If it contains the course, then there's two possible states. If the status of C is true, then it's done, which means it should already be in this list. So what happens if we see a dependency? Oh, so we're seeing a dependency on something that's already done. So in this case, we're just good. And we don't need to process anymore, so we can continue. Else, if the item, if it's not been fully processed, that means we have a dependency on something that hasn't been done. And I think this is our failure condition. Which means if we make it all the way through this mess, then we're true. Okay, so then in here, what we'll do is, assuming we make it through this, which means we've never seen this one before. Oh, I haven't constructed my adjacency list yet. All right, we'll do that in a minute. So here we'll basically say like adjacency. Nothing looks right. Adjacency list, let's see, basically your items for each. I need to do all this stuff again. So we'll make this a new function called, it's a standard DFS here. That takes in a value, C, which is an integer. Ugh, which means I also need to pass this stuff. So we'll name this something better in a minute. DFS, we'll give it our value. It also needs to know about our status map. And we do not have to pass the done list. So the status list is sufficient. Okay, so status here is our mutable map of integers and booleans. Okay, and so in here, for each of our children, we'll call DFS on it, passing the status, passing our cache. And if this returns false, what does that mean? If we get false from here, do we meaning we depended on an item that wasn't done yet. So I'm not sure about this yet, but I think if we get a false from here, then we need to return false. So if any of our children are false, we are also false. If we're true, we can continue. I'm getting lost now. Okay, then I actually need to populate the status at some point. So if it doesn't contain C, then we should add C. Status dot, or rather at C equals false. It's not been processed. And then down here, once we're totally done, we can set that status to true. And remember, when the status is true, that's basically our good condition. Okay. So this is the part wishy-washy about. And so in here, we basically just need to track this, and what we'll do is a DFS search from every node. And so high level, what are we saying? I think I'm doing that thing where like I recognize a problem, and so I start kind of like typing what I remember of the solution rather than thinking through the solution again, which is usually a bad rabbit hole for me. So I'm probably going down a bad path here. I may have underestimated this problem. Let's see. Maybe a variable acyclic equal to true, and acyclic equals acyclic and that. And if we ever see a false, we could exit early. Sure, why not? Okay, now this part feels weird to me. So we are going depth first, that's good. And if one of my dependencies says no, oh look, I'm never even appending to done here. I don't think I need to care. I just need to know if I could get through it. Alright, let's try some simple examples. I'm certain I didn't type this right, but just for fun, let's see how many errors I have. If this works, it would be a miracle. Okay, that's more like it. Break and continue are only allowed inside a loop. Okay. Yeah, I'm fine with that being there. Okay. Other stuff, 24. It's not a unit. Return. Is that because this isn't marked as returning true or false? So you should return true here, which is a Boolean. All right. Oh, I never did construct the adjacency list. Okay. And what is the adjacency list? Well, it is a mutable map of integers that points to a mutable list of integers. Yep, I'm good with that. forgot it doesn't like control F. So where did I even use my adjacency list? Oh, in here, which means I need to pass it. Seems more important than the status. I'm passing 3 variables now. Warning, warning. Also not a good sign, but in challenges like this, I will accept it. Mutable map of mutable lists. So fine, now I need to actually construct that. And we know the number of courses. And do the problems say how many courses? 0 to number of courses minus 1. Okay. So something like, sure, C again, in 0 dot dot numCourses. Ooh, I think that's inclusive. Oh man, this is probably an error. Equals mutable list of integers. All right, I probably have off by 1 error there. So I think that'll fix it, and there's a better way to do this. I just forget what it is. IntelliJ's been babying me for too long. Mutable map of should not be of. Just a map. How y'all doing, by the way? Happy Friday. I'm very excited about it being Friday. I'm enjoying the last few days of my 30s. It's been a good run. numCourses at C, that's not right. Adjacency list at C. Equals. Okay, and when I read it, I know that it's not null. Okay. Thank you very much. You know, it's Alan's birthday. Very soon as well. This weekend? Oh, my camera's off. Weird. Maybe I fixed it. Maybe I made it worse. Find out. Cool. So I'm editor. Hey man, Gemini's unite. Mutable map int list. Okay, it's IntelliJ time. I tried. Not only am I incapable of coding Kotlin without an ID, I don't even want to. This is a course schedule test. All right. Oh yeah, look at that. Is status return true, else return false? Okay. Result equals DFS of status and adjacency list and status. There we go. All right, that's better. Could be private. All right, fine. I'll bite. Down here, it's going to tell me what the thing was until 0 until the number. Okay, was that it? Do I dare run it without actually trying to run it in IntelliJ first? Maybe I'll get lucky. After I get this problem, I'll look up an actual way of doing a top sort. I don't know if the thing where you like pluck off the leaf nodes is like a good solution. I don't know the runtime of that. Null solution. Okay. You win again, Kotlin. You win again, unit tests. Call it a simple test, sure. Give it a 2 and an array of an int array. Of and 0, 1, so this one should be good. Actual dot equals true. All right, and it sounds like this was a syntax or a null pointer exception. So hopefully I'll get that here. Okay, we got a line number. So I did pre-fill my adjacency list, I think. I did use poor variable names. So the chance of this being messed up is very high. So C should have all the items from 0 until 2. So that should definitely contain whatever C this is. It's an integer. I call it on DFS. And I call DFS somewhere around here. There we go. 0 ... numCourses. Yep. So here I did until. There I did ... Should both be until. That would be nice if that was the only error. I doubt it. All right. So, simple failure test. You like my unit test names, by the way. Simple failure. I think they give it one in the example where they had another array. It says 1 depends on 0. This should equal false. I really need to figure out how to write parameterized tests. Ooh. I gave a true here. Not good. 0 depends on 1, 1 depends on 0. Should definitely have been false. I think that's probably okay. That is probably also okay. Let's get this out of the way. Table driven. Is that what it is? Table driven tests? Table driven. .NET calls them, or I should say NUnit calls them. Oh my god, I'm getting old, man. Same thing. Oh geez. Table driven tests. NUnit parameterized tests. Yes, and they look like I expect because I'm used to this. Where? Yeah, test case. There's the input and there's the output. There we go. Yeah, so that's what I want. So Kotlin, which is really just JUnit. JUnit table driven test. Yes. Parameters. Oh, so you define a class. Okay. Parameterized.class. Okay. So then who calls this thing? Whoa, I'm lost. So there's the tests. How does it know to like put those two together? Where's the second class? Annotation magic. Okay, so it just like knows like, oh hey, find the thing with the parameters and hook it up. Make it available. Dynamic tests. Whoa. It looks for the parameters and runs the test case over and over with those parameters. Okay. Okay. Let's try it. So if we said you run with parameterized class, I believe I've got JUnit. Yep. Already. Okay. This is going to be one of those Java class thingies. Okay. And down here, yeah, it probably is like .java class, or I forget how. It looks like it's not necessary here, which is suspicious. Okay, and then in here I could have a parameters annotation. I don't know what that means. Fun. So they have it static. And it returns the input. So I could say, I mean, JVM static. Fun. I don't know, get tests data. And it's going to return. What is going to return? Arrays as list, so a new list of inputs. So I basically say like, maybe like the arguments are, oh, it's like a triple. I don't really want to define a new data class for it, but I guess it's either that or do a triple. A triple of an int, an array. Oh my gosh, this is getting complicated. An array of int arrays. And then I need the result that I expect, which I'll actually put up front as Boolean. So I'll be returning a list of that. Nothing looks right. Maybe static doesn't matter. Okay, so in here, we'll just return a list of, and I'll have a triple of true, 2, and then whatever this was. Oh, that's a triple of that. There we go. And one that's kind of similar. That's false. Okay. One depends on 0. And we don't need to specify return type. It'll figure it out for us. What is wrong here? Array of dupe, 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 dupe. Oh, there we go. Okay. So we've got a parameterized test. So now could just get rid of this one. And I want the magic. How do I get the magic? So I just have the test. And then I create private variables. Wow. The private variables look something like, yeah, sure, convert it. Something like this, where we've got a Boolean called expected. Okay, Boolean called, I don't know, an integer called nums or something, numCourses. Give it a default, and these need to be vars, I think. And then this is going to be whatever they called it. Prerequisites. Oh, that's funny. I'm never using the prerequisites variable right now. That is definitely a mistake. So, yeah, in addition to initializing my adjacency list, I actually need to fill it up. So, that's a pretty big miss. So, this is not going to work very well. So, for each, basically, we need to mark a dependency that says adjacency list at the key it dot first, it at 0, depends on it at 1. And it'll work, trust me. Okay. Well, now I just kind of want to try the original test. Let me just do that real quick. All right, awesome. No public static parameters on course schedule test. Let me try this. Okay, first test still works. Fine. Let's try the simple failure. The only kind of edge case I could really think of was the islands, things that have no dependencies. But those should always work out anyway. Okay, so I still got the wrong answer here. Oh no, no. I forgot to update the test. That was good. I didn't mean to hit debug here. Ooh, so this worked. Do we have any other samples? They don't give us any others. Let's try them. So that was IntelliJ realizing that I hadn't used a variable. So very glad for that. Oh, hey, you just saw your comment there. Yeah, using a companion object instead of JVM static, using get test data. All right, let's submit. I think this is it. Yeah. All right. Hey, not too shabby. The best solution. A little bit tidier on the initialization. What? Okay, almost identical on the initialization. Then they created a queue, it was a linked list, so that's what I started doing. And then I decided that I didn't need it. Oh, what's offer? I've never seen offer before. I usually did take first or whatever. It's pretty cool. So they're doing a BFS, it looks like. They basically have a priority queue. So they're doing BFS instead of DFS. I wonder why that is. This looks like a standard BFS to me. So if they have an item in degrees, and it's not equal to 0, when do they set it equal to 0? not equal to 0. I'm not quite sure how to interpret that, but it basically looks like my solution, but BFS instead of DFS. So check this out. So if we look at like top sort, topological sort, yeah, here we go. Okay, so this Kahn's algorithm is like the one I was kind of talking about, where you choose vertices in the same order as the eventual topological sort. So first you start with a list of start nodes which have no incoming edges. So those are, I called them leaf nodes because I was thinking about it like a tree. But really they're just the ones that they're not depending on anything else. You remove them, and then you should be able to find at least another one. So you have to keep going over the list over and over again to see if there are any that you can take out of the list. And every time you take it out, you also have to remove any other dependencies on it. And then eventually you should be able to come up with a list that works. Oh, excuse me, what's the runtime? What does that mean? The absolute value of the vertices plus the absolute value of the edges? Or the cardinality of the vertices? The number of, okay, yeah, so kind of like cardinality, the number of nodes plus the number of edges. And depth first search. So the thing about reversing, what was that? Was that strongly connected components? Connected components? There's like one algorithm where you have to, the trick, and it's like, I think it's really hard to figure out on your own, but like if you know the trick, it's not so bad. Or is it minimum spanning tree? Man, the fact that I don't remember what these algorithms even do means I need to revisit them. Oh gosh, this is gonna drive me nuts. That's not what I'm looking for. Decision trees. Man, I don't remember that. I thought it was topological sort, where there was like a trick where you kind of like, you did something to reverse. Let's see, graph, reverse edges. I don't remember. Reverse a directed graph. So you, like with an adjacency list, you basically just go and you kind of transpose it. So you go through each item in the list and you create a new node there or append the item that was dependent on it. But I wanted to see like what that was used for. And I only know so many graph algorithms, like I only know the names of so many. So it's got to be either minimum spanning tree, I thought it was topological sort, or strongly connected components. So there's path between all pairs. This is it. We can find all strongly connected components using Kasara Jews. I apologize. I'm not going to be able to say that. I apologize to you, Mr. K, or Mrs. K. Sorry, that was awful. Create an empty stack and do a DFS. In the DFS, so it's similar to what we've done. After recursive DFS, push the vertex to the stack. Then reverse the directions of all arcs to transpose the graph. So we do a DFS first on an adjacency list, then we reverse it. And then one by one, we pop a vertex from the stack while it's not empty. And if we get through that successfully, then that tells us that all nodes are strongly connected. And the definition of strongly connected, I kind of forget. It was like all nodes are connected by at least like 2 lines or something. Well, now I need to look that up. Strongly connected if there's a path between all pairs. All pairs. Oh, so for every two, so there's no islands. Okay. No, I am misreading it. So there are 3 strongly connected components here. Okay, this description is not doing it for me. Whew. Each vertex is reachable from every other vertex. Okay, so to look at that picture again. Okay, so one is reachable by every other. What? Graph of the next week strongly connected. So graph. There's a path between all pairs of vertices. So there is a path from 0 to 2. There's a path from 0 to 1. There's a path all the way back to 0. Okay. So 3 is separate because 3 has no way to get over here, and 4 has no way to get here. So the 3 strongly connected. Okay, good. So good thing the problem wasn't about strongly connected components, because that would have been rough. But now we remember, next time we see a problem for strongly connected components, like if we are trying to find out groups of things in a graph that are able to get to all of each other, and the trick is to keep a stack while you're doing the DFS, and you basically keep the done nodes in the stack. And then you reverse the directions, transpose. After you've done that, you pop an item from that stack, do a DFS on it, and as long as it's able to complete with the pop v strongly connected. Okay, and once the DFS completes, you've got a strongly connected component. Okay. Phew. Okay, well, hey, y'all have a good one. Thanks for hanging out. I am going to go to bed or play video games. I don't know which one yet. Hope you have a good one. Ciao. Oh, and I'm going to look up, let me try to see if like there's Kotlin table driven test JUnit. And just get like a Kotlin example. See what that looks like. Whoa, this is not looking like I expected at all. Table headers, what? Okay, this is over my head. Nope. All right, bale dung. Hook it up. Data-driven test. Test factory. We annotate it. Okay, this is using the dynamic tests in JUnit 5, which should be fine. Dynamic test.dynamic test. Okay, this is hurting my head. It's Friday, y'all. I'm outie. I'll learn that some other day.